Good afternoon and welcome to today's webinar entitled Interior Finish Firestopping. My name is Anna Diaz and I will be your moderator today, along with John Zalepka, who is our Senior Manager of Engagement and Programs. We would like to take a moment to review some housekeeping items before we start. All attendees will be muted during the webinar. We have disabled the chat feature during this session. However, questions can be sent in the Q&A section at the bottom of your window. We will gather your questions during the webinar and hold a question and answer discussion at the end. We will be reporting AIA credits for those who attend at least 75% of this live webinar. If you have an AIA number and did not give it upon registration, please send it to webinars@stifirestop.com. If you're not a member of AIA, you can use your certificate of attendance to self-report to whichever agency you wish. In addition to your certificates, STI has partnered with Credly to provide you with a digital badge of your credentials. Digital badges can be used in email signatures, digital resumes, and shared on social media sites. And finally, a recording of today's webinar, along with your certificate of attendance, will be uploaded to our Firestop University within the next 5 business days. You can connect to our Firestop University through your Access STI dashboard, which we will tell you about at the end of today's session. Please remain with us until the end of this presentation to receive instructions on how to retrieve your certificate. And now I would like to introduce John Zalepka.
Thank you, Anna. Interior finish fire stopping is a critical component of fire safety in buildings. It helps contain fires, slow their spread, protect escape routes, maintain structural integrity, and safeguard occupants' lives. Our presenter today is Corey Pantuzzo, Strategic Account Manager for our Strategic Initiative Interior Finish team. And today, Corey will cover the basics of interior finish and joint system designs for fire stopping, the different joint types, how they're tested, and what to look for when choosing the correct system. This presentation is copyrighted and has been developed by Specified Technologies, so please do not reproduce, redistribute, or display any material without contacting us first. This course has been approved for one learning unit, HSW, with AIA, and as part of the continuing education requirements, here are today's learning objectives. At the end of the program, you'll be able to identify different joint types. You'll be able to recognize movement capabilities and the differences between static and dynamic joints. You'll be able to describe what fire ratings of floors and walls are and identify the different types of rated and non-rated partitions. And with that, I'll turn it over to today's presenter, Corey Pantuzzo. The floor is yours.
Thank you very much, John. In today's Interior Finish Fire Stop training, we'll be covering the following topics. We're going to start with a brief discussion of what fire stopping is and what the codes will require. Then we'll get into how we as manufacturers test different types of joints in walls and floors. We'll talk about joint movement, product installation, and how to make sure that you have quality code compliant installation. And then we will address any questions that you might have. Let's start with the understanding of what Firestop is and what it is not. Firestop is different than any other trade, and each of the pictures in this slide is an example of life safety building system that is required by code, and they all have one thing in common. They're installed by one craft. Here we see sprinklers, dampers, and alarms. It's crazy to think that fire stopping systems are not always installed by one trade. Spray ply fireproofing is used to protect structural steel from these high temperatures that can cause critical structural columns and beams to fail in a fire, bringing down a building. And in other words, spray applied fireproofing, like most of these services you see on the screen, is almost completely dependent upon the installer to apply it properly to ensure that it will perform as it's designed in an actual fire. And at the same time, it's true for fire stopping. It's completely dependent on the installer to apply it properly. However, there is no law or legally recognized union requirement that ties fire stopping to a particular trade. Thus, it becomes a virtual free-for-all. You know, some trades consider fire stopping to be beneath them. Most, if required to self-perform, simply take the lowest ranking labor, hand him or her a caulking gun and say, go squirt this in the holes. And often out of ignorance or lack of education, the wrong products are chosen, wrong systems are used and not followed properly, and it is implied incorrectly. A hardening caulk may be installed around a high traffic opening of low voltage cables, which almost certainly require a subsequent change, that will require subsequent changes in the future. Water sensitive products may be installed in areas of high humidity. I could go on and on about all the problems that I see in the field, but instead I'm going to just move on to the next slide. So first, let's start with the definition of fire stopping. Simply put, it is the process of sealing openings around penetrants or in joints to restore hourly fire resistance ratings. So if we have a fire rated assembly and we put a hole in it for whatever reason, whether it's to install an outlet box, HVAC ducts, cabling, pipes, any of the typical services that make a building livable, every time you penetrate a fire rated wall or floor and create an opening, you have compromised that barrier. So in order to restore the performance of that wall or floor, you will need to fire stop those penetrations. In the case of joints, you're essentially blending two fire-rated assemblies together to create a continuous envelope of protection. So any voids or unsealed joints in any fire-rated construction will also compromise that barrier. So if we have a fire-rated assembly and we make that hole for whatever reason, you have to go back and make sure that it is filled in. And again, we're trying to do this to restore the performance of those barriers. So for these barriers to be effective, they must be continuous and all openings must be sealed. Just one unsealed or improper opening and you no longer have a rating. So now let's define Firestop products so that we're all on the same page. Firestop products are specifically formulated, independently tested fire-resistant materials for sealing penetrations and joints in fire-rated construction against the spread of fire and smoke. Fire stopping is an important part of the containment and balanced fire life and safety plan. Shown here are some typical applications. On the left, you have a typical head of wall joint where a gypsum wall runs into corrugated decking, where an elastomeric spray is commonly used. Next to that, to the right, you have a data cable penetrations where Easy Path has been installed. Next are Firestop pillows protecting a cable ladder, penetrating a block wall. And finally, we have your everyday intumescent sealant protecting the opening that was made for a metal pipe. Now let's take a look at what the codes require, specifically about our interior finish joints. So on this slide, why do we fire stop essentially? Well, because it's required by the building code. These codes are cited in the International Building Code, also known as IBC. You can find them in NFPA 101 Life Safety Codes, NFPA 70 National Electric Codes, and others. Many of you also have state codes that are even more stringent, like in California or Las Vegas, Nevada, that you really need to follow. But for the most part, they mirror IBC when it comes to fire stopping. All model codes have required fire stopping and smoke protection in one form or another. And for many years, the requirement has been refined and clarified over time. So now we've answered why we fire stop. The question is, where do you fire stop? It's easy to say for, fire rated walls and floors, but when you're on a job, how do you know which wall and floor is fire rated? Best case scenario is to look at your building plans. You can see very clearly in the life safety drawings which barriers are called out as fire rated and which ones are called out as non-rated. But if you're an older building and you're doing a remodel, those plans may have been out of date or may not exist anymore. So you want to look at things that are present in the construction that may indicate it is a fire rated wall or floor that can tell you if proper fire stopping is required. An easy one to look for is doors and windows. If you look on a door frame or a window frame, you'll often see a little tag or marker. And if it's a fire rated assembly, it'll call out not just the third-party lab that the door or window frame was tested in, but also what the rating of that door or window is. You can also look for things like fire dampers, would be another dead giveaway. There may even be stenciling on the wall that will tell you the hourly rating. These are just a couple of signs that you can look for if you don't have the building plans. The International Building Code defines a joint as the opening in or between adjacent assemblies that is created due to building tolerances or is designated to allow independent movement of the building in any plane caused by thermal, seismic, wind, or any other loading. Control joints are used to prevent the cracking of the overlaying materials and systems applied over the structure. While drywall is considered a flexible finish, it will crack when movement occurs in the underlying structure if control joints are not installed properly. On the right here, you can see a concrete wall. This is a wall-to-wall joint. It allows one concrete element to move independently of other parts of the building or structure. These joints also let it shrink as it dries, preventing what's called internal restraint. Now, internal restraint is created when one part of the slab shrinks or moves in another direction of the other slab. That's why it's important to have a product that can move with the joint, such as an elastomeric spray that we see in the picture on the far left, or an elastomeric sealant that we see in the middle or on the right. We will address movement a little bit more as we get into the training. So what is UL's definition of a joint? Well, its joint systems are specific constructions consisting of adjacent wall and floor assemblies and the materials designed to prevent the spread of fire through a linear opening between the wall and or floor assemblies. The photo on this slide shows SpeedFlex joint profile being sprayed with AS205, which is another way to tackle these head of wall joints. Now, important code sections like 715 is where you can find the general definition of a fire-rated joint. But notice at the bottom of 715.1 that the fire-rated joint shall be tested in accordance with section 715.3. So what is section 715.3? Well, if you look closely at the bottom of this slide, code section 715.3 will define the requirements of how the fire-rated wall and joint are tested, either to ASTM E1966 or to UL 2079. ASTM E1966 and UL 2079 are tests applicable to joint systems of various materials and construction. They are intended for use in linear openings between adjacent fire-resistive structures, and they are tested to between 1 and 4 hours for fire-rated assemblies. For your reference, here's a chart illustrating a cross-reference of ASTM and UL standards. Through penetrations are tested to ASTM E814, and UL 1479. Joints are discussed as tested to ASTM E1966 and UL 2079. And curtain walls are tested to ASTM E2307. Now, for fire-resistant joints, ASTM E1966 gives you, fire resistance and temperature readings, and UL 2079 builds on that ASTM standard, giving you additional smoke and air leakage and water resistance ratings. You can look for these referenced test standards on your product labels or use the product data sheets to make sure that you are using the correct product that was tested in accordance with the application that you're doing. A common question that we get is what are the requirements for ceiling penetrations and joints and smoke walls? Well, it's important to note that smoke wall can be classified as either a smoke barrier or a smoke partition. Now, smoke barriers need to maintain a minimum fire rating of 1 hour so it can pass the resistance of smoke and superheated gases. Where smoke partitions, on the other hand, have no fire resistance ratings and are only required to resist the free passage of smoke. So for smoke partitions, smoke and sound is commonly used. And in case you don't believe me, you can see the reference on the screen found on the International Building Code, which we will discuss further after we see how fire-rated barriers are compromised. Now, building code requires that smoke barriers not only carry the fire rating we just discussed, but must also obviously be designed and constructed per their name to restrict the movement of smoke using an L rating. Now, this requirement measures how much of that air leakage or smoke, what that rate is going through a fire-resistive joint system or penetration. So not only are we preventing the spread of fire, we're also really limiting the spread of smoke. So now let's cover how third-party testing agencies use these standards to test fire stop assemblies. When it comes to third-party testing, there's UL, also known as Underwriter Laboratories, which many of us are familiar with, but we also test through Intertech as well as Factory Mutual. And each one of these labs are going to conduct testing to the respective ASTM and UL standards. All of them are nationally recognized labs, and all of them have equal status as far as being acceptable. All these labs have listings that meet the code requirements in the building code. Therefore, the code doesn't say where the testing must happen, only that the testing must be done to a particular standard and that each of these labs is capable of running these respective tests. However, for the purpose of our discussion today, we will focus on UL systems because UL is probably the most widely known and most widely used. Now, before we can select a product to use, we must start with a system. Always, always start with a system because how we get the correct UL system involves many parameters that need to be followed. First, I like to start off with what are the barriers or the assemblies that we're dealing with. Second, what type of construction joints are we looking for? And lastly, what are the fire stopping materials needed? Is it mineral wool and spray, mineral wool and sealant? Maybe it's sealant only, or you're possibly using now our gasketing material. Now, when it comes to joint construction, it has its own numbering system. And with joint fire stop systems, the two characters that start off the system refer to the joint type. So the HW highlighted in red for the system HWD0043 stands for head of wall. BW would stand for bottom of wall. FF would stand for floor to floor, and so on as the slide reads. The second character in the numbering system refers to the movement capability of the joint. So the letter D in this example designates that the joint is dynamic, and the S means that the system is static. So dynamic means that the joint will have movement, and static will have none at all. The first numbers of the joint system refer to the range of the joint sizes that the system falls into. In the example above, the 0 indicates that the system is for a joint that is 2 inches or less in width. If it was a 1, it would be a joint that was between 2 and 6 inches, all the way up to the 4000 series, which are joints that are up to 24 inches. The system itself, once you find the one you are going to use, will list the maximum joint size that was tested on the very top of the system card. And then, of course, the last 3 numbers of the system refer to the individual system itself, meaning the HWD0043 was the 43rd system in the 0 series of dynamic head of wall joints that was tested. So the last few numbers will be specific to the manufacturer who actually tested the system. HWD0043, for example, is an STI tested system. Now, here are a few things to consider when you are selecting the system. You want to make sure you are within working range of the nominal joint width, and you want to make sure that you also have the correct hourly rating. If you're expecting movement, how much are you expecting in compression or extension? Lastly, once you choose a system, you need to know if the system requires mineral wool, and if so, what is the correct mineral compression and the sealant depth. So how do we actually go about selecting the correct UL system? Well, there are many parameters that need to be followed. First, I like to identify the barriers. Like I said, is it concrete or CMU? Then I like to identify the type of joint. Is it a head of wall, bottom wall? And then from there, what type of fire stopping is needed? Is it mineral wool and spray? Is it mineral wool and sealant? Maybe it's sealant only if you prefer that. Maybe you want to use a gasketing material. So make sure you're going through and you're selecting these. Then we need to verify the movement requirements, like I said previously. And I like to hit on this because this is something that seems to get missed a lot. And when it does get missed, it can cause problems and delays on the job. You also want to identify, is there any outside characteristics? Is there a beam running along the wall, or is there a beam running through the wall at your head of wall joint that we may need to consider? There are always plenty of options to choose from, so make sure you choose the application that would work best for you. And on our website, we have a system selector that makes this process very easy. And if you would like training on this, reach out to your local territory manager and let them know, and we can get that done. So now that we're through the testing section, let's jump into different types of fire-rated walls and floors. This slide represents a few of the most common fire-rated wall types. The first one you see when it pops up here, there we go, is your standard wood stud wall. The second one here is your steel frame wall. And the last one here is a steel stud shaft assembly. But also be aware of other fire-rated assemblies like V400 and the Gypsum Association fire resistant design assemblies. These are just the most common that I see all the time on a job site. So how do we get a fire-rated wall assembly? First, we build the wall, incorporating the framing members, and typically 5/8 gypsum installed on both sides of the wall. Now, most people assume a 1-hour gypsum wall will survive for 1 hour in a fire, and while that seems logical, it's really only partially true. When you look at this slide, you'll notice the wall breaking down on the exposed side of the fire side of the wall. And according to test standards, there only needs to be no flaming on the cold or unexposed side of the wall. Notice the wall is starting to break down, and according to ASTM E119 or UL 263, as long as you don't have that flaming, it's the layers that are on the unexposed side that need to last. The layers on the fire side rarely last 50 minutes before they start to fall apart. So as long as there's no flaming or smoke going past the cold side or the non-fire side, everything that's on that front side will be sacrificial. Now, I know I just spoke about fire-rated wall designs, but I wanted to touch on a few different types of fire-rated floor systems. While there are many out there, I've seen a ton. I'm going to review the ones that I see most often. And on the left, we have a flat concrete slab assembly. In the center, we are working with a fluted deck topped with concrete. And on the right is precast hollow core floor assembly. And the reason I'm talking about the fire-rated floor systems is due to the code requirements. The code requires both substrates to be fire-rated for construction joint assemblies. So if one of the assemblies is not rated within the building, then none of them will have a rating. So now that we're through the wall and floor construction, let's talk more about the different types of joints that you'll see. Again, construction joints are gaps that are intentionally left between structural members of the building that allow it to expand or contract without causing any damage to the building. And in this depiction on this slide, you see a variety of construction joint types, and we'll get more into each kind over these next few slides. So these are the 5 types of construction joints we encounter every day. The first is a wall-to-wall. These occur where one wall intersects another wall, or a vertical cut sometimes is put into an existing wall. Then you've got your floor-to-floor. These occur, of course, where 2 floors intersect. You've got your floor-to-wall. This is where the edge of the slab intersects a vertical fire barrier, such as an elevator shaft or possibly a curtain wall application. And then you've got your bottom wall. These occur at the intersection, of course, the gypsum assembly and the top surface of the floor. And finally, the most common of all joints is the head of wall joint that you can see in the very middle. The head of wall is between the top of the wall and the bottom of the floor deck above. So most walls in steel and concrete construction are not load bearing, and this means that they rest on the top of the concrete slabs as barriers, but do not serve to support the floor above. So therefore, there must be a gap between the top of the wall and the floor above. And this gap is not sealed. If this gap isn't sealed, in any way, that allows smoke and gases to get through. It will not be compliant. When you do seal it, it will allow for movement and will stop the products of combustion. Now, head of wall joints can have fluted deck, it can have flat slab, it can incorporate typical gypsum wall assemblies and shaft wall assemblies, but most head of wall joints are dynamic, which is noted in the UL system with the HWD, as we spoke about earlier. And systems with HWS as the prefix are static and therefore will not have any movement. This system shown here has a rating between 1 and 4 hours and a maximum joint movement of 2.5 inches. And for these wider joints, like the picture in the slide, an elastomeric spray is most often chosen because it is faster to apply and does provide the flexibility and movement for those bigger joints. Now, most bottom wall systems are static, usually due to the fact that the wall is going to be moving with the floor and not independently of it. So the attached detail allows for 1 and 2 hour walls and has a maximum gap of 3/4 of an inch. This means that any joint 3/4 of an inch or smaller will be acceptable, provided you can install the proper amount of sealant within the joint based on the system standards. Wall-to-wall joints can also be dynamic or static. Notice the prefix to see which one is which. And not to be overly repetitive, but WWD is a wall-to-wall dynamic, where WWS would be static. This joint is designed between 2 concrete or CMU walls and has a fire rating of up to 3 hours and a max 1-inch joint. And then here in this slide, you see a floor-to-floor, and we're looking at a system FFD 1010, which has a 1 and 2 hour rating, a max 4-inch joint, and varying levels of movement. In the system, it shows 15, 25, and 35% movement depending on the joint width it is called out. And then finally, we have our floor-to-wall systems, and these systems can be dynamic or static as well. FWD 1006 has a 2-hour fire rating, a max 4-inch joint, and class 2 movement capabilities at 15% compression or extension. So now let's get into joint movement. We spoke at length about why joints are designed, and it's because we know that the building's going to move. So here's how we test these Firestop systems for different movement classifications. This movement is done prior to the burning of the joint and is designed to stress or weaken the materials, making the burn portion of the test more critical. As you can see on the slide being displayed, it does show class 1, 2, 3, and 4. And these are listed by category. It lists the number of cycles and the cycling rate that each class must test to. So how do we achieve movement? Well, the typical installation of the framing is that the top of the track is mechanically fastened to the underside of the deck. Then the studs are typically cut anywhere from 1/2 inch to 3/4 of an inch short and are nested in the slotted track, and the gypsum is held down from the bottom of the deck. This allows clearance for the top track and the gypsum to compress and extend as the floor moves. When treating these head of wall applications, using a spray applied coating for gypsum walls is the most common application for these joints. The movement in gypsum wall will occur between, of course, the top of the gypsum board and the underside of the concrete floor where the mineral wool is stuffed. This movement area, which is depicted in the photo, is where you would install a strip of mineral wool or the STI product SpeedFlex joint profile. And here we go. All right. Now, a head of wall joint that is listed at 50% compression or extension and a nominal 1-inch joint would be cycled in the following manner. Starting at the nominal 1-inch joint position, the joint is compressed down to 1/2 inch, and then it extends back up to the 1 inch, which is the starting position. And then it is extended out to 1.5 inches, and then back to the nominal 1-inch joint. So that would constitute one complete cycle. This animation gives you a clear understanding of what that movement capability looks like. Now, maintaining proper joint area when on a job site when you're installing the gyp board is the most important, because you need to allow proper installation of the mineral wool or the preformed strips, allowing for that movement. Installing gypsum board with a very small joint or even too tight to the deck makes it almost impossible to install the mineral wool correctly, and it doesn't allow the joint to move the way that it's required to. As a design professional, keep in mind that certain parts of the U.S. may require greater movement capabilities, like California or Alaska, where deflection is required to be installed with an improved joint system per section 715, like we discussed earlier from the IBC. The assemblies need to be designed to allow joints to compress and extend. And I always like to clarify with the architect, if possible, how much deflection is required in compression and extension, as it's not always spelled out very clearly. I was just recently on a job where the contractor assumed that the 1-inch deflection that was noted was 1/2-inch compression and 1/2-inch extension for a total movement of 1 inch, but came to find out that the architect was actually looking for 1 inch in compression and 1 inch of extension, which was 2 inches of total movement, meaning that he needed to cut out his joints and make them bigger in order to get the movement that was required or that the architect was asking for. Always clarify that what the architect means, because a lot of times it's not spelled out that clearly. Now, penetrants installed at or near the top of wall can interfere with proper movement of the joint system as well. So some head of joint systems do have ceiling track designed to allow for deflection, and rigid penetration item can inhibit free movement. So you got to be aware that there are fire test standards for head of wall joint systems imposes specific temperature limitations on the unexposed or the non-fire side of that test assembly. So any penetrants that you have there that conduct heat may cause temperatures to exceed test standard limitations, so penetrations are just best to be avoided. Instituting a no-fly zone, such as explicitly restricting the penetrations within 6 inches of the head of wall joint, can be a good construction practice. And it's also important to note that nothing in the building code precludes penetrations in these areas, but these areas are designed for movement. So any penetrations that do go through there may break or may cause issues. So next up on our outline, we have installation requirements for fire-rated joint systems. Now, section 715.2 refers to the installation of a fire-rated joint system. The code is essentially giving us instruction on what type of materials need to be used. Now, obviously, a brittle product like drywall, mud, or mortar would not satisfy the building code, as these materials, when put in the wrong locations, do not allow for movement and will most likely crack or dislodge as the building moves. Top of wall joints that abut fluted metal decks are most commonly stuffed and sprayed. This process involves, filling the joint with the mineral wool, which is compressed to the required percentage by the listed system, and then spraying the joint on each side of the wall with an elastomeric or Firestop spray. The install requirements of the spray, that it must be required a dry thickness of 1/16 of an inch when you spray it, and that it overlap a wall or floor above and below by the amount stated in the listed system, which is typically 1/2 inch. The overlap would need to be increased to 2 inches if the deck or structural members are protected with spray applied fireproofing. And again, this elastomeric spray is applied to resist the passage of hot smoke and superheated gases. All right. Give me 1 second here. It looks like this is, here we go. So starting from the top left, we see mineral bad insulation, uncompressed. Here, the grains in the concrete orientation are running vertically or what would be parallel to the exterior before compression. The second picture on the bottom left shows correct compression of the mineral wool bad insulation with it installed correctly. The next picture on the top right shows it uncompressed mineral wool with the grains running horizontally, or what would be perpendicular to the building's exterior, which is incorrect. And finally, the last picture on the bottom shows when you compress that mineral wool, when it's put in there incorrectly, it does not have that nice look, and it will crumble and just not look very good. That's how you'll know that that is stuffed incorrectly. So to allow for movement between curtain wall joints, that mineral that is inserted perpendicular to the joint and compressed to the popular percentage The biggest issue with curtain wall fire stopping outside of having the correct testing is maintaining the correct orientation of those mineral fibers. So you got to make sure that they're put in that slot properly. To allow for that proper movement, like I said, ensure that the mineral orientation is installed per the listing. The cut or the grain side of the wool should be visible when you spray over the top of it. Now, here's a chart that we put together that easily calculates the amount of mineral wool needed for many different size joints. A lot of times I've gone out to jobs and I've seen where they're not using the correct size of wool, or they're not putting the correct amount of wool in there. So this chart makes it very easy. If you have a 10-inch curtain wall joint and you need 30% compression, all you have to do is go down to the 10 inches on the joint and then 30%, and that gives you your 14.29. But the math, if you're ever to do it by yourself, is 10 divided by 0.70, which gives you that 14.2857. Now, gun grades are great for those narrow size joints, like where we see concrete walls that are close together. In a situation like this, you may not want to pack mineral wool or bring a sprayer on site. Here, you may just want a little backer rod along with the Firestop sealant, or sometimes you may even just use that sealant just by itself. That is one big advantage of using sealants over sprays, is that sealants don't always require a backing material. But again, check your respective UL system to determine if a forming material is required. So now I'm going to go over quality assurance and myths about fire stopping. And in this section, we will focus on installation issues that can cause failures to happen. These failures are usually caused by adhesion, cohesion, substrate, or three-sided adhesion issues. But most issues that I see in the field are usually caused by not cleaning the surface before the material is applied or sprayed. Now, both silicone and acrylic Firestop materials are designed to have a good bonding characteristic. However, the bond will fail under certain conditions. Adhesive failure can happen if the sides of the joint are contaminated with the oil or dust or dirt, and the bond of the sealant to the substrate may fail when the joint moves. To prevent this, just make sure you always clean the surface before you apply material. In cohesive failure, after the sealant or spray has been applied and it has dried, it may tear apart from the movement of the joint. Now, this can be caused from excessive joint movement or from simply choosing the wrong sealant or possibly choosing the wrong system for your application. Substrate failure is when the material to which the sealant or spray has been applied fails. So if a sealant or spray is bonded to a very old material, it may come loose or break. So if you are bonding to a surface that you can see is worn down, make sure you spray an additional maybe 2 to 3 inches overlapping that material onto the surface, and that can help prevent the substrate from failing. If the sealant is bonded to both sides of the joint, it will expand and contract like a rubber band. However, if it is also bonded to the third point, like the back of the joint, it can no longer stretch and it will be torn apart, which is caused by three-sided adhesion. Now, three-sided adhesion can be avoided by applying bond breaker tape or the use of mineral wool, so it's only bonding to the top and bottom. So when you use that bond breaker tape and that mineral wool, it will only bond to the top and bottom like you can see in this slide here, but it allows that third portion where your sealing runner is to flex away from it. Now let's discuss some myths about fire stopping, because I hear stuff every day, all the time. It's very common to hear that red is right, fire stop has to be red, but actually in the code, there's no requirement about color. A lot of installers or manufacturers, I should say, choose it, just chose red because it was more easy to see. But we custom make colors. You can use any type of color when it comes to fire stopping. Our last myth about fire stopping is a joint compound can be used as a fire stop. I know we talked about this earlier, but when you use joint compound in a joint, it will break away and can fall out, which will not make it compliant and can cause issues. So again, joint compound is great for other parts of building the wall, but when it comes to fire stopping and allowing movement, it is definitely not acceptable. To make sure you get proper installation of fire stopping products, is it a best practice to take a look at hiring an FM 4991 approved contractor or a UL certified contractor. These professional fire stop contractors have gone through programs that certify and comply with the knowledge of quality control procedures. They have minimum 2 years of experience. And to find a contractor local to you, please go to fcia.org and you can search by state or call your local STI territory manager for assistance. Now, what do you get with an FM 4991 or a UL certified contractor? Well, everything listed in this slide. You get experience, you get make sure that they're properly licensed and bonded, and you get a contractor that knows what they're doing. And that concludes the AIA portion of this presentation. And now I would like to show you some of STI's construction joint products. I know we spoke about different types of materials for construction joints throughout the presentation, but now we dig a little deeper into the construction joint materials that STI does offer. First up is our elastomeric sealant. ES is a premium grade Firestop sealant for joints. It's highly elastomeric with movement capabilities of 25% compression and extension. ES is 100% paintable when dry and comes in 2 standard colors, which is pale blue and red. It has excellent tooling capabilities and is listed in over 45 UL certified systems, including head-of-wall and bottom-of-wall, wall-to-wall, floor-to-wall joints. ES is available in 10-ounce tubes, 20-ounce sausage tubes, and 29-ounce quarts, as well as 5-gallon pails if you like to bulk load. Next up, we have our LC endothermic Firestop sealant. LC is water-based endothermic sealant designed for both construction joints and metallic through penetrations. What LC does is it absorbs the heat and releases water to keep the penetration or joint cool. It is also paintable and will not shrink as it dries. LC has movement capabilities of up to 12.5 inches of total movement and is an excellent smoke seal. LC comes packaged in 10-ounce tubes, 20-ounce sausages, 29-ounce quarts, and 5-gallon pails. Now, AS200 is our spray-applied elastomeric Firestop material. AS is perfect for use in fluted deck or for larger construction joint applications where high performance and production is required. AS is 100% paintable when dry and has movement capabilities of up to 100% when used with SpeedFlex joint profile, and I'll touch on that in a second. When AS is used with standard mineral wool, you can get up to 50% compression or extension, and it is water resistant and won't re-emulsify once dry. AS 205 has been tested to systems up to 4 hours. It can be applied at head-of-wall joints, perimeter joints for curtain wall or floor-to-wall, floor-to-floor joints. It even has a few through penetration systems that it can be used for. AS comes in 2 standard colors, pale blue and red, and is only available in 5-gallon pails. If you do need it in gray, we can make custom colors, so reach out to your territory manager to give them a heads up on that as soon as you can, because it does take a while for custom. Now, SpeedFlex joint profile, which I've mentioned a few times throughout these slides, is a fibrous joint material that is for use at top-of-wall construction joints. SFJP, as it's commonly called, to replaces the strip of wool in the joint area between the gypsum board and the steel deck. It allows for 100% movement of a variety of joint widths and has tested systems for up to 2 hours after 1/8 of an inch wet coating is applied. SFJP is 40 inches long and comes in heights of 4 and 8 inches, depending on your movement criteria. Now, systems like HWD 8046 use SpeedFlex joint profile that allow 100% movement capability and can move up to 3.5 inches in total movement. Now, our SpeedFlex track top gasket, it is a patented thin profile intumescent cover for gypsum wall framing tracks, runners, and studs that is designed to provide fire, smoke, and acoustical ratings for head-of-wall joints, wall-to-wall joints, bottom-of-wall joints, and it can even be used in some curtain wall applications. TTG is compatible with most sealing track and provides an economical method of providing the required seal in rated and non-rated construction walls installed on the track prior to installing. The walls are effectively sealed against fire, smoke, and sound transmission. TTG is one of those products that also allows up to 100% movement capability. Just double check the joint sizes in the systems. We make it in red and black, so it's easy to inspect as you're assembling the wall. It is not susceptible to cracking or sagging or any dripping, and it is also water resistant. So when used properly, you have very minimal waste. TTG comes in multiple sizes. We have TTG 350F and 600F, which is designed for 3 5/8 and 6-inch slotted track. Both the 350F and the 600F come in 160-foot lengths. Our TTG 250J, TTG 400J, and TTG 600J are designed for the different sizes of J-track that you'll see on the job. TTG is totally customizable and can be manufactured to meet other track sizes. The last product I'm going to review is strictly for acoustical or non-rated walls. These walls are often sealed with smoke and sound sealant or spray. Smoke and sound spray is applied using a paint sprayer and is perfect for use on fluted deck where high production is required. Just remember that these both stop the passage of smoke and are only for non-rated application. Both products are white in color and paintable. Smoke and sound sealant is available in 20-ounce and 29-ounce quart tubes, while smoke and sound spray is available in 5-gallon pails. And the sealant is also available in a 5-gallon pail if you want a bulk load. They are safe for plastics, which I know a lot of other materials are not. They are water resistant, so they will not re-emulsify. They do remain flexible, and they're acoustically tested to reduce the sound transmission. And that concludes my portion of the training. And so now I'm going to pass it back to John.
All right. Well done, Corey. Let's roll on to that next slide so we could test the knowledge of our listening audience here. Anna, are you ready to launch the poll?
Ready, John.
All right. Don't sound so excited. All right. Anna's going to launch the poll right now. I'm going to read through these questions, and you're going to make your best guesses. Hopefully they're not guesses. Go ahead and launch that poll. I don't know if you did or not. I'm having some technical difficulties on my end.
I did launch it.
It's on?
Yes.
All right. So I'll read through. Question number 1. Proper installation of mineral wool will allow the wool to compress and rebound to its original form. Is that a true or false statement? All right. Number 2, construction joints are used to, prevent cracking of the overlay materials and systems applied over structure? Do construction joints provide a means of evacuation from the building in an emergency? Are construction joints used to protect the building interior against the exterior natural phenomena such as sun exposure, temperature changes, earthquakes, rain, and wind? Or is it D, all of the above? We're looking for what construction joints are used for. All right, number 3. A system that has failed because the concrete it is applied to is weak and has crumbled loose is an example of, is that adhesive failure? Is that cohesive failure? Is that substrate failure? Or is that just a decisive failure? All right, make your selection now, and then we'll move on to number 4. Firestop is the process of sealing around openings, around penetrations, or in joints to restore an hourly fire resistance rating. Is that a true or false statement? All right. And then finally, this is applied as coating over wider construction joints. Are we talking about elastomeric sprays? Are we talking about composite sheets? Is that going to be a Firestop mortar? Or is that going to be a pipe collar? All right, we'll give you another moment or two to just make your selections. And then don't forget to hit submit. And then Anna, give them a couple seconds more, and then we'll roll on to the next one. All right, so Corey, yep, there we go. Moving along. I can't see what the percentages are. So Anna, you'll tell us. Number 1, how many people got that one right?
86%, John.
86% got it right.
People are
Proper
listening.
installation of mineral wool it's designed to compress and rebound. All right. Number 2, the correct answer, as you see, is A. How many people got that one right?
48%.
48%. It was worded a little funny. It was a little bit of a tricky question, but yeah, construction joints are there so that they're going to move. They're designed to move so that you don't have cracking of that overlay material, whether it be your gypsum wall or your floors, whatever that joint is. So tricky question there. So number 3, a system that has failed because the concrete it is applied to has crumbled. That is going to be a substrate failure. And how many got that one right?
74%, John.
74%. All right. Good job. Nice rebound there.
Yes.
No pun intended on the mineral wool. All right. Firestop is the process of sealing round openings. That's a very basic question. That's a true statement. I'm hoping to hear 100% on this one, Anna.
96.
96. There's always somebody. There's always somebody. All right. And finally, number 5, this is applied as a coating over wider construction joints. And there, yes, we're talking about our elastomeric spray. And how many got that one right?
83.
83%. Great job. All right. We're going to pass the entire group. And now we're going to roll on to some of your questions there. Corey, if you don't mind, let's see what's going on.
Working on it.
All right. Might have to close that poll off. There you go. All right. So we have the QR code there. Please leave us some feedback. We have some STI swag bags. We always do a winner there. So let Corey know how he did. Let us know if you're liking these webinars. And then we're going to get into some of your questions here. Like I said, I'm having some technical difficulties. So Ann has been sending me your questions. Let me see. I'll go back. Corey, where are you going? There you go. There's your face. There's your mug. All right. Let's see. Where are these questions here? All right. I can't see the questions. Anna, can you read the first question?
Sure. So the first question is: a rated joint required to seal fire barrier head or base of wall joint to a non-rated wool floor ceiling assembly where a non-rated lid or floor is required? I guess that's the first part of the question.
Well,
and if a rated joint is required, is STI working on producing listings for such joints?
There are exceptions to the rule. So when you get to the roof and it is a non-rated roof, you can have a rated application there, even though it is a non-rated roof. But if you're in the middle of a building and you have like a non-rated floor going to a rated wall, they have to find a way to make that floor rated and that wall rated in order for all the barriers to be rated. So there are exceptions to the rule, and we can, I guess, discuss that further offline if need be.
Yeah, I'll jump on that a little bit, Corey. I mean, the latest edition of the IBC, you may not know this yet because it's not even adopted yet anywhere in the 2024 code. It now does have requirements for when the rated wall runs into the underside of a non-rated deck. Again, that's something that is not adopted yet. So if you are encountering some of those conditions, reach out to us so that we can get you in touch with our engineers and they can get you a design that will work for you there. All right. Next question. Let's see if I can find it. Are there any head of wall joints that allow for 3/4 inch deflection and 3/4 inch extension other than the flexible spray? Now, the joints are typically measured in percentages, so we would need to know how big it is, but it sounds like if you have a typical 3/4 inch joint, they're asking if we have products that can go 100% compression and extension outside of the spray. And I think I'm answering the question for you, Corey, but the answer is no. You probably would need to have spray if you needed that type of percentages. Again, without knowing your total joint size, 3/4 inch doesn't really tell us 50 or 60%. But if it is 100% in either direction, you may actually need to use a speed flex joint profile. I believe Corey showed you that. That will allow you to get that 100% compression and extension that you're looking for there. Corey, anything you wanted to add to that?
Nope, hit it perfectly.
All right, thank you. Nailed it. All right. A question came in about a new 2021 requirement for fire stopping submittal and documentation. I'm not 100% sure. It was more of a statement than a question. So they wanted us to talk about that. I'm not sure if it was a requirement. And I'm not sure if they're talking about the special inspection for Firestop. So as of 2012, there has been a special inspection for Firestop that includes pre-construction meetings, which would also include your submittals and all that type of documentation. But that is up to the local authority having jurisdiction to enforce that. So even though that is part of the code, again, that's why we do webinars like this to make people aware of the different code sections. But yes, it would have to be enforced, anything that would require submittals or documentation, things like that. And I can't see if any other questions are coming in. So anything else popping up there that you want to read to Corey? We only have about 5 minutes left, so maybe one more question if there is one.
Sure. It was mentioned that joints between a rated element and non-rated element cannot be tested because of a code or testing requirement that requires elements on both sides of the joint must carry the same rating. I don't know if this is a question or if this, does the roof structure's rating need to be increased just because of the wall that is attaching to it? This is probably something that we may want to answer offline because it's a long question.
Yeah,
This
that's we kind of touched on that already a
Yep.
little bit there, as far as the code requirements are going to be kicking in a little bit more on the 2024. But if there is that condition, it sounds like that's a very similar condition to one of the other questions we had. Firestopping cannot give a rating to something that never had it to begin with. So when you have one non-rated wall going up to a rated wall, you're not going to be able to get a Firestop system there. The underside of a non-rated deck, again, that's kind of what we're talking about here. So get in touch with us, either email Corey or reach out to us. We'll show you a couple other ways to do that as we roll through some of these slides. But any other questions, we'll get them over to Corey or we'll get them to our engineers and we'll answer them offline for you. But Corey, let's roll on to some of these other slides here. All right, so this has been brought to you by Specified Technologies. Firestopping is our only business. We're here to provide you with innovative, cost-effective firestop, smoke, and sound solutions. On the next slide, you'll see that we truly are a global company. There we are. We're globally based in beautiful Somerville, New Jersey. There's my map. There it is. But we do have worldwide sales offices and warehouses, so we have you covered wherever you are. Next slide there. Access STI. So this is where you'll want to grab your phone right now. If you don't already have an Access STI account, smash that QR code, get yourself a free Access account. You'll be able to get in touch with all of the digital tools we're about to show you, including where your certificate will be in a few days. It's going to be in our Firestop University. So once you create your Access STI account, you'll be in your dashboard. You'll see something called Firestop University. Head over there. You'll be able to get your certificate. Again, give us 3 to 5 business days. I just made the turnaround a little tighter, Anna. Sorry. All right. So System Search and Submittal Builder. Here's another QR code for you. This is an app for either your iPhone or your Google phone, Samsung, whatever you have there. We have you covered. This is so that you can access all of our systems. We have over 1,500 systems with or without Wi-Fi. So this is a great tool to have on your phone, your iPad when you're on a job site. Next slide shows you a great picture of our engineering support crew. So these people are available Monday through Friday, 7 a.m. to 7 p.m. Eastern time. You can email them, you can call them, or as you see there in the corner, you can even start a chat with them. So if you're on a job site, you come across a wacky condition, take a picture, start a chat. You can get some answers while you're there with your inspector. Keep moving. All right, Corey. You keep moving too, please. All right. So if you're a specifier, you're a designer, architect, we have a lot of great tools for you. Guide specifications. So if you're just cutting and pasting some old spec language, don't do that. You might be missing out on some new code language, new standards, things like that. So we have guide specifications. You can download those. They're easily editable Word documents on our website. We can also do a full comprehensive specification review for you. Again, all of this, no charge. All of our products are BIM objects. They're on our website, and we even have an awesome tool called Firestop Clash Management. It's built as a plug-on to Autodesk Revit, so you can actually pre-select Firestop systems and tell your subcontractors what to do. So Firestop Locator is a great documentation tool. So if you're doing work in healthcare facilities or you're in the inspection game, check that out. Again, no charge to try it out. Couple more slides for you. Barrier management program. So if you have a new job starting, reach out to your local territory manager. We can help you to coordinate your subcontractors, mechanicals, electrical, plumbing contractors, along with those interior finish folks, drywall contractors. Gets everybody on the same page. We can either do it as a old school analog binder that you can keep on your job site, or we're up to date with the digital also. So reach out. We can help you coordinate all the trades. Here's what Firestop University homepage looks like. Again, get your Access account. Head over to Firestop University. This is what it looks like. On the next slide, you'll see a bunch of courses that we have available as playback there. We've done a lot of webinars. There it is. So if you need some continuing education credits as you go through the end of the year, we have you covered over on Firestop University. Again, that's where you'll be able to find today's certificate in just a couple of days. And then finally, the Credly badge. You're going to get one of these also in addition to that certificate that will be on Firestop University. This will come as a separate email. Anna, anything else? We're at 3 o'clock. You have 30 seconds.
30 seconds. Okay. Just want to remind everyone that we will be reporting AIA credits for those of you who gave us their member number and attended at least 75% of this live webinar. If you have an AIA member number and did not give it upon registration, please send it to webinars@stafirestop.com. And lastly, you will all receive an email within 3 to 5 business days when the recording and certificates are ready. If you have not created an Access STI account yet, please make sure to use the same email address you used to register for today's webinar when creating your Access STI account. That's all from me, John.
All right, that was 37 seconds, but that's fine.
Sorry.
All right, great job, everybody. Corey, great job to you too. You want to say goodbye to the fine folks here?
Yep. Thank you guys for having me. I appreciate it. And I hope you guys have a great rest of the week.
All right, we have 2 more webinar Wednesdays coming up, so we'll see you next week. Take care.
Bye, everyone.